body of mass, let's say 2 kg, which has been projected up at an angle of 45 degree, either with the x-axis or y-axis, one and the same thing, with a velocity of 20 root 2 meter per second, we have to find the angular momentum of this body about O at t is equal to 3 seconds. We have to find its angular momentum. So by our knowledge, what we did in projectile motion, and now we combine it with our understanding of angular momentum and we proceed. We know that is angular momentum is equal to r cross mv. So now we need two things, r we need and v vector. These two things we need. So how to proceed for that? Let's understand. So velocity, when we have velocity of 20 root 2 meter per second at an angle of 45 degrees. So first thing what we do is we break this into two parts, because eventually we shall be needing over here, that is mv is here. Otherwise this is a momentum and this distance, perpendicular distance, we have to multiply these two things and it will be in this direction, that is into the plane of paper. Let's find v and we find r and then we proceed in a usual manner, r cross mv. So in projectile motion, what we had been doing earlier also, we break this velocity into two parts. One is along x-axis, the other is along y-axis. If you remember, that is acceleration along x-axis is equal to 0 because there is no force along x-axis, and along the y-axis it is 10 meter per second square in the downward direction. If we follow sign convention, what we did earlier also, motion under gravity, so it is g is 10 meter per second square downwards, and acceleration along x-axis, that is equal to 0, and acceleration along y is g in the downward direction, and g we have been taking as 10 meter per second square for the ease of calculations. So when we break this velocity into two components, this and this, and first we intend to find what is velocity. We find what is the velocity along x-axis. So vx is equal to ux plus axt. Ux is 20 meter per second. This component comes out to 20 meter per second. That is 20 root 2 cos component. Cos component is 1 by root 2. That is cos 45 is 1 by root 2. So it is 20 meter per second. Similarly, this comes out to be 20 root 2 into sine 45. Sine 45 degree is also 1 by root 2. So this also comes at 20 meter per second. So both the components, they come out 20 meter per second, 20 meter per second. 20 meter per second, 20 meter per second. Vx at t is equal to 3 seconds. The velocity component along x-axis we intend to find. We'll find Vx also, we'll find Vy also. Similarly, it comes from here to here, so this is position vector. We'll find this displacement vector along x-axis and we will find the displacement vector along y-axis also. From there we can find the r vector and then we'll do r cross mv. So that is how we are going to proceed. So velocity along x-axis over here is, we use Vx is equal to ux plus axt. That is the equations of kinematics. Ux is 20 meter per second, ax is equal to 0, so this comes out 20 I cap. In this direction, we are taking the vectors positive, I vector positive. Vy is equal to uy plus ayt. Uy is velocity along the y-axis, initial velocity along y-axis at this point. It is 20 plus ay is, we are taking it as minus 10. That is all the vectors in the upward direction. We have taken it positive. In the downward direction, we have taken it as negative. G is in the downward direction. So that's why we have taken it as negative, that is minus 10 into 3. So this comes out minus 10 j cap. So if we have to say what is velocity vector at 3 seconds is going to be 20 I cap minus 10 j cap. So this is velocity vector. Momentum is, obviously we can multiply with 2 kg and we can find the linear momentum of this. Now comes, what is this r? For this r, we find this Sx. Sx is going to be what? Uxt plus half axt square. Acceleration along x-axis is equal to 0 because all the time only earth is pulling it downwards. So the only force is always along the y-axis. There is no force along the x-axis. So that's why acceleration along the x-axis is equal to 0. So Sx is equal to uxt plus half axt square. Ux is 20 into t. T we have taken as 3 seconds plus half axt square 0. Though this comes out to be 60. So 60 into I. This is Sx is going to be 60 I cap. Now Sy cap. Sy is equal to uyt plus half ayt square. So 20 into 3 plus half this thing. So this comes out to be 15 j cap. So this is comes out to be 15 j cap. So what is this r? Triangle of vector addition. This vector is equal to this vector plus this vector. So r vector, if we write in vector notation, so it is 60i plus 15j. Now L is equal to r cross mv. R cross mv vector. So this comes out to be, r is what? 60I plus 15J cross what? M into V. We can directly multiply M. This is scalar quantity with the vector quantity. We can directly multiply. So this is 2. This is 2 kg. This is 2 kg. 2 into 20. 40I minus 20J. Now you know easily, that is, how do we find the vector product of this? You can easily find out, and you can find out the answer. It is going to be, that is, because R is in this direction, R is in this direction, and velocity is somewhere is in this direction. You can, so this is R vector is in this direction, velocity vector is in this direction, this is the angle. So momentum is also in this direction. So R cross MV, R cross MV. So answer should be, you can check this answer, it should come out to be something in minus K cap. That is, the angular momentum about this is into the plane of the paper. Angular momentum is an axial vector. Angular velocity is an axial vector. Torque is an axial vector. So these are axial vector, and the direction is perpendicular to the plane.